Hello everyone, welcome back to Vyas IAS CSAT course, lecture number 43. In this lecture also we will continue with permutation and combination. Some of the conditions of permutation and combinations were left. So we will see that in this video and we'll move forward to look at the questions. So let's begin. Okay, let's begin. Um, all right. Um, So look at these question. Look at this concept. Sorry, look at this concept. We have a condition. We have also discussed about this condition in the last class as well. So total number of selections of zero or more things out of n different things. Okay. So you are, let's say, given 10 different things and you have to select zero or more things out of that. Okay. So in how many ways you can do that? So for example, I'm giving you an example. You have one iPad. Okay. You have one Samsung tab. You have one iPhone. Okay. You have another Samsung phone. You have a one Note. You have a one Plus. Okay. You have a, let's say, any other company phone. So we have in total one, two, three, four, five, six, 7 items. Okay. So out of these 7 items, what is the total number of ways? What is the total number of ways in which you can select zero or one item? Okay. So see what can happen here. I can either you can select zero item, or you can select one item, or you can select two item, you can select three item, four item, five item, and six item. Okay. Now this zero item, if you will select, you can do this only in one way, when you are going to select one item out of these seven. So you can do this in 7 ways. Okay, you can do this thing in 7 ways. If you want to select two items, if you want to select two items out of these 7 items, you can do this in 7C2 ways. If you want to select three items out of these 7 items, you can do this in 7C3 ways. If you want to select four items out of these 7 items, you can do this in 7C4 ways. And if you want to select five items out of these 7 items, you can do this in 7C5 ways. And if you want to select six items out of these 7 items, you can do this in 7C6 ways. And if you want to select 7 items out of all these 7 items, you can do this in 7C7 ways. Okay. Now, see what is happening here. I am saying that in general, if we are given n different things and the total number of ways in which we can select zero or more things out of n different things, so that can be given by what? NC0 plus, okay, what is NC0? NC0 is 1 only. Okay, then this is what? This is NC1. This is what? This is NC2. This is what? This is NC3 dot dot NCN. Okay. So this is given by NC0 plus NC1 plus NC2 plus dot dot NCN equal to 2 to the power n. So when you will solve this everything, so you will find that the sum total of these will be given by 2 to the power n. So total number of ways of selecting zero or more things out of n different things is given by 2 to the power n. So you have 7 different things and you have to select the number of ways in which you can select zero or more things out of this is given by 2 to the power 7. Okay. So if you have understood the concept, if you have understood the concept, why I am saying this, why this formula came, I think you will have to like memorize less. You will just have to memorize one thing, that you, when you do this NC0 plus NC1 plus NC2 dot dot NCN, so that is equal to 2 to the power n. Okay, that is equal to 2 to the power n. So this is how you do these kind of questions. Now look at this. The number of selections of one or more things out of n different things is given by. Okay. So we are talking about number of selection of one or more things out of n different things. Okay. So here you will avoid the condition of zero because it is asking you have to select at least one thing and you can select the maximum number of things. So just that case you are going to subtract from here and that will be it. Okay. Just that case you are going to subtract from here 2 to the power n minus 1 and that will be it. Okay, so this is how you do these kind of questions. Now let's move forward. Now, see, number of ways of distributing n identical things among r persons when each person may get any number of things. Okay, so we have now n. Okay, so see, this is actually the condition in which we are saying that, let's say we have 27 marbles and that have to be distributed to four people such that each one of them can get any number of marbles including zero marbles. Okay, so then for this situation, how we can do this thing? Okay, so this is 27 marble and we have to distribute this among four people. So how can we do this? See, either I give zero marble to this one marble to this one, two marble to this one, and the rest, how many marbles are left? 24 marble to this one. Okay. Or I can give what? One marble, two marble, three marble, or 20. Uh, this will be 21 marble. Okay. So in this way, so many cases will come. Okay. So this can be given by what? N plus R minus 1 CR minus 1. Okay. So this is actually what? See, I have 15 identical things. So n identical things I am having, or let's say we have these 27 marbles. So 27 identical marbles we are having. Okay, and we have to distribute them among four persons. So what I will write here? 27 plus 4 minus 1, and here I will write 3 because r minus 1, 4 minus 1 is 3. Okay, so how much I am getting? 30C3 I am getting. Okay, 30C3 I am getting. So basically it is what? Basically it is that you have n identical things, you have r different person, okay, and you have to distribute among them these n identical things such that each person may get any number of things, okay, including zero. So that can be given by what? That can be given by this formula: n plus 1 r minus 1 c r minus 1. See, if you will revise this PDF multiple times now, you will be able to remember all the cases. And the number of times you are going to revise this PDF, actually what will happen is that each time you revise, the comprehension of the concepts will increase. Okay, so do this thing again and again. That will like very much consolidate your preparation in permutation and combination. Okay, so let us move on to the next. Now see, number of ways of dividing n non-distinct things to r distinct group can be given by n minus 1 cr minus 1. Okay, so let's say I have 15 pair of bangles. Okay, and I have to give this to like three group of women. So in how many ways I can do this? Okay, so that can be given by n minus 1 cr minus 1, and in this case we are not distributing 0 to anybody. We have to give something to each one of them. Okay, we have to give something to each one of them. Okay, so number of ways of dividing n non-distinct thing to r distinct groups. Okay, so that can be given by what? N minus 1 cr minus 1. So I have 15 pair of bangle. Okay, I have three groups. So in how many ways I can distribute these pair? 15 minus 1, and this is three groups. So 3 minus 1. So that will be 14C two ways. Okay, 14C two ways. Now look at this. Also, the number of ways in which n distinct thing can be distributed to r different person. Okay. The number of ways in which n distinct things can be distributed to r different person, that is given by r to the power n. Okay. So number of ways in which n distinct things can be distributed to r different persons. Okay, so you have n distinct things, that means you have seven different items. Okay, and that has to be distributed to r different person. Okay, earlier when we were taking n plus 1 r minus 1 c r minus 1, so in that, see, what was the condition? That n things were identical, r were different person. Okay, here what is there? N things are distinct and you have to distribute to r different persons. So that can be given by r to the power n. Okay, r to the power n. So see, understand these cases. We have these three conditions: number of ways of distributing n different things, Okay, or number of ways of selecting n different things. So that is given by what? NC0 plus NC1 dot dot NCN, which is equals to 2 to the power n. Then we have a case in which number of ways of distributing n identical things among R persons. R persons. So that is given by what? N plus R minus 1 CR minus 1. Okay. And number of ways in which n distinct thing can be distributed to r different person. So we have n distinct thing, and we have to distribute it to r different person. Okay, so that can be done by what method? R to the power n. So we did a question, we had four different rings, and that had to be distributed to three fingers. Okay, so that was done in how many ways? 3 to the power 4. So that is what? R to the power n. Okay. So same concept. I hope you understand the difference between these concepts. Now let's move forward. Now see, number of ways of dividing m plus n different thing in two groups containing m and n things respectively. Okay. See, what the question is saying here, number of ways of dividing m plus n different things in two groups containing m and n things respectively is how much? Okay, see what I am saying here, that I am taking, let's say, any figure r equal to m plus n. Okay, uh, okay, so I am saying that I have 14, let's say, mm, 14 different things. Okay, I have 14 different things. I have one pen, one pencil, one book, one auto rickshaw, one cycle, one, let's say, a cough syrup. Okay, one bottle, one earpods, one book, and all these things. So I have 14 different items. Okay, 14 different items, and I have to divide these 14 different items into two groups containing m things, let's say containing 6 things in one group and 8 things in one group. Okay, see, obviously 14 items, if you have to divide in two different groups, so you can divide either 6 thing in one group or 8 thing in another group, or you can okay, so let's say 14 different items, and I have to divide this into two groups of m and n respectively. Now see, these two groups can be any number. Now this m and n can be any number. Either it can be 7 and 7, either it can be 8 and 6, either it can be 9 and 5. Okay, either it can be 10 and 4. Okay, so this m and n can be anything. So if m and n items are there in these groups, so what is our formula? M plus n c n, because what will happen, first you have this m plus n number, so that is you have 14, and then out of them, let us say you are selecting n things, so 14c6 into how many things will be left now? 8 things will be left, and out of these 8 things you will select 8 things only. Okay, so that is given by m plus ncn into mcm. Okay, into mcm. So this is what? M plus n factorial. Okay, divided by what? M factorial and n factorial. And this is what? This is m factorial divided by m minus m factorial and m factorial. Okay, and m factorial. So this basically becomes what? This basically becomes m plus n factorial divided by m factorial and n factorial. Okay, this basically becomes m plus n factorial divided by m factorial and n factorial. Okay, fine. So I hope everybody understand this. What is here? See, understand this thing. When you are selecting MCM, so that means out of m items you are selecting m items. So this will be one. This will be one way only. So once you have selected n items out of m plus n items, your thing is done. Okay. So you can, so number of ways of doing this can also be given by m plus n cn. Okay, but it's okay if we write this. If there are different kind of questions, that will be very much familiar to us. Okay, so understand the whole formula. See, we have like let's say 14 different items. We have a group of 8 and we have a group of 6. So I'm, let us say if I'm selecting this group of 8 first, so I can do this in how many ways? 14 see 8 ways. And I can do this in how many ways? I can do this in 6 ways. Why? Because now only 6 items are left. Okay, so this will give me what? Factorial 14 divided by factorial 8 and factorial 6. Okay, and this will give me factorial 6 divided by factorial 6 and 6 minus 6 factorial. So this and this will get cancelled. So I'll get what? Factorial 14 and factorial 8 and factorial 6 here. Okay, so this is how we do these kind of questions. I hope you understand this. Now, number of ways of dividing two n different things in two groups containing n things, that is equal to 2n factorial divided by n factorial and 2 factorial. Okay, so number of ways of dividing two n different things. So you have two n different things in two groups containing n things. Okay, so see, first of all, always identify what is given in your problem, whether these are different things or whether these are identical things. So we have two n different things, okay, and we have to divide into two groups containing n things each. So this is nothing but the same case that m plus n c n and MCM. Okay, so but in this case, m plus n is what? 2n. So one you will write Cn and then other will be NCN. Okay, then other will be NCN. Now see, uh, if we are dividing in equal groups, okay, if we are dividing in equal groups, okay, so see what will happen here. We'll get what? Factorial 2n, okay, and factorial n, okay, factorial n and factorial n, and we'll get here what? N factorial divided by 0 factorial and n factorial. Okay, so this will get equal to 1, but we will divide here by 2 factorial. Okay, we'll divide here by 2 factorial. See, these are n different things, n different things. Okay, fine. So these are basically either I put n different things in one place, or I put n different thing in one place. The case will be same. Okay, the case will be same. Okay, so we have to divide 2 factorial because the number of things in both groups are same. So there is one case that will be repeated if we don't divide that by 2 factorial. Okay, so for example, if I am like, let's say um I have 8 things. Okay, I have or let's say I have 4 things. Okay, I have 4 things, which is pen, pencil, book, and let's say sharpener. Okay, so I have pen, pencil, book, and sharpener. So number of ways I can divide this in group of 2 and 2 is how much? Okay, so let us see. Okay, so either I can keep pencil and pen and pencil here, okay, or I can keep book and sharpener here, okay, or what I can do, I can keep pen here and I put book here, okay, and I can do what? I can put pencil here and I can put sharpener here. Okay, I can put pencil here or I can put sharpener here. Fine. See, this is one way. What is another way? Either see, this is pen, this is pencil. Okay, so now I will put what? I am taking pencil here. Okay, I am taking pencil here. Now pencil and sharpener case is already done. Okay, pencil and sharpener case is already done. So I can put pencil and book here. Okay, I can put pencil and book here. And here, see, book and sharpener case is done. Pen and sharpener case is done. So book and what is not together? See, pen and book is together. Pencil and book is together. Book and sharpener is together. Do we have any other options? We don't have any other options. Okay, let us check for sharpener. Sharpener and book are together. Sharpener and pencil are together. Okay, sharpener and pencil are together. Okay, and sharpener and pen. Okay, sharpener and pen are not together. So basically, how many ways we are getting? 6 ways. Okay, 6 ways. Let us check by this formula. So this formula says 2n factorial. Okay, 2n factorial, the number of ways of dividing 2n different thing is given by 2n factorial divided by n factorial and 2 factorial. So 2n factorial is actually what, 4 factorial, and what is n factorial, 2 factorial divided by 2 factorial and divided by 2 factorial. So we have this 4 into 3 into 2 into 1, okay, divided by 2 factorial into 2 factorial into 2 factorial. Okay, so this comes to be what, this comes to be this comes to be, this 2 and 2 will get cancelled, this 2 and 2, and this comes to be. So we have total 3 number of ways. Okay, we have total 3 number of ways. Okay, so look at these relationships. NCR plus NCR minus 1 will give you N plus CR1. CR. Okay, so what basically we are saying, that NCR plus NCR minus 1 will give you N plus 1 CR. Okay, so remember this equation. And then whenever you are given NCX is equals to NCY, so N is equals to X plus Y. Okay, N is equals to X plus Y, or X is equals to Y. Either one of these condition will satisfy. What I am saying here is, if you are given NCX is equals to NCY, so N is equals to X plus Y, or Y, or X is equals to Y. Okay, either one of these condition will satisfy. Okay, and then you have this R dot NCR is equals to N dot N minus 1 CR minus 1. Okay, N dot N minus 1 CR minus 1. So this is also very evident. Why? Because you have R. Okay, so NCR can be written as what? NCR is factorial N divided by factorial R N minus R factorial. Okay, so if we write this as, factorial N as N minus 1 factorial N into N minus 1 factorial, we can write this as, okay, and this r can be written as r into r minus 1 factorial, and this is n minus r only, let us say. Okay, so see what will happen here. Now we have written this and we are doing r here, so this r and r will get cancelled, this r and r will get cancelled. So now you have got n dot n minus 1 and c r minus 1 factorial. Okay, and c r minus 1 factorial. So this is how these equations are there. You don't have to remember each of these because you don't have to give like maths examination, but still these can help you. Okay, and ncr divided by r plus 1 can be written as n plus 1 cr plus 1 divided by n plus 1. Okay, see, the most easy way to remember these relation is to look at them again and again. Whenever you look at some formula again and again, you will remember that formula. Okay, now these are not so important from UPSC or CSAT perspective, but it can help you in another competitive examinations. Okay, now see, if NCR has to be greatest, and if n is even, then NCR will be greatest if r equal to n by 2. Okay, if number of ways of selecting n things, sorry, number of ways of selecting r things out of n things. Okay, so that is greatest if n is even and r equal to n by 2, and if n is odd, then r will be equal to n plus 1 by 2 or n minus 1 by 2. Okay, so then it will be greatest. Okay, so remember this thing, that whenever the maximum value we have to find, so that will come when NCR is there and n is even. So r is equals to n by 2, and NCR when it is there. Okay, so if n is odd, okay, and r is equals to n plus 1 by 2 or n minus 1 by 2. Okay, so this is how we do this. Now look at this thing, number of selection of r things out of n different things. Okay, number of selection of r things out of n different things. So see, when R, there are R things, okay, and we have to select R things out of n different things. Okay, so if k particular things are always included, okay, so we have R things to select. Okay, we have R things to select, and we have to select them from n number of things. And if k have to be only always included, then we don't have to consider this k in our calculation. So we will do what? N minus k C R minus k. Okay. So if I am saying to you that I have pen, pencil, okay, bottle, rubber, mouse, digital pen, okay, and I am saying mouse and digital pen have to always be selected. Select four things out of these 1, 2, 3, 4, 5, 6 things. Select four things out of these six things, and always select mouse and this digital pen, and select two other things. Okay, so basically what they are asking, that you tell me out of these four things in how many ways you can select two things. So that will be 4C2. Okay, so that is what it is saying. Two things have to always be selected. So 6 minus 2 C, 4 minus 2. So that is what 4C2. That is no brainer. It is no formula. It is just common sense. See, we have this condition. Okay, consider this condition. If you can't see this thing clearly, it is actually NCR minus N minus K CR minus K. Okay, NCR minus N minus K CR minus K. Now, number of selection of R things out of N different things, it is saying. We have to select R things out of N different things. So, let's say I'm taking 7 things. Okay, and out of these, I have to select four different things, and I am saying that I have 7 things like A, B, C, D, E, F, G. I have these 7 things, and I have to select four things out of these things. But I am saying don't ever select this F and G. I don't want this F and G in my selection. Okay, so what I will do basically, see, number of ways in which I will not select these things. Okay, number of which I will ways I will not select these things. Okay, so see, k particular things are not together in any selection, it is saying. Okay, k particular things are not together, so that means first try to consider all the selections, all the selections of r things you can make out of these, and then subtract the number of selection in which these k particular things are uh, always together. Okay, so you will get when all the k particular things are not together in any selection. Okay, all the k particular things are not together in any selection. Okay, so if we are taking any case in which this k particular things are always together, so sir, both of these are always together, so and we are selecting them also. Okay, so what we are doing this, we are not considering them. Okay, because that is the case in which these k particular things are always together. So that case will be given by what? N minus k C R minus k. Oh, why? Because see, let's say I'm giving, I said that select four things. Okay, select four things, but this F and G should always be together in that. Select four things out of these 7 different things. Select four things, but these F and G should always be together. So what you will do now? You will only give me the answer. In how many ways you can do it? So out of these 5 things, only 2 things are selected to be left. So your answer is 5C2 when these two particular things are always selected together. Okay, when these two particular things are always selected together, so that number of cases is 5C2. So that is what? N minus k C R minus k, because n is what? See, n is what? 7, and 7 minus k is that is 7 minus 2, and you had to select four different things. So 4 minus 2. So this becomes what? 5C2. Okay, this becomes what? 5C2. Okay, so you subtract this when these k particular things are always together, and you take the entire number of selections that you can make of r things. So out of these 7 things, okay, out of these 7 things, if I'm telling you to select 4 different things, so that can be done in 7C4 ways. And when you are removing all these things, okay, when you are removing all these things, when these both are always together, so that will be 5C2. So this will be your answer. I hope are able to understand this. See, listen to this once more. I am saying I am saying this question is saying number of selection of r things out of n different things when all the k particular things are not together in any selection. Okay, so I am giving you that you have this A, B, C, D, E, F, G, okay, you have these 7 different things. Okay, you have these 7 different things, and I am telling you select 4 things out of them, but don't ever select this F and G. Okay, don't ever select this F and G. So first I will do what? I will find the case where I can select out of 7 different things, I can select 4 things. So that can be done in 7C4 ways. Okay, that is very simple. This can be done in 7C4 ways. Okay, now these both things are not ever in my selection. No, this both things are actually, this case is saying they are not together in any selection. Okay, so see, when these are together in selection, so I am selecting these both. Okay, so when I am selecting these both, how many selections more I can make? Out of 5 things, I can select now only 2 things. So that number of things I will minus. So I'll get when these both of these are not together. Okay, both of these are not together. Okay, but they can be single. Either F can be selected or G can be selected, but both of them are not selected together. Okay, so that is the number of ways I am subtracting, and then I am getting my final answer. So I hope everybody is able to understand this thing. Okay, now look at this. Number of ways of doing a work with given restriction is equals to total number of ways of doing it minus number of ways of doing the same work with opposite restriction. Okay, so the same concept I told you when it was saying to me that select are different things out of n different things when two things are not always together. Okay, so what I did was I calculated always together wala condition. Okay, always together wala condition, and then I subtracted it always together wala condition in with total number of ways of doing it. So what I did is number of ways of doing a work with given restriction is equals to total number of ways of doing it minus number of ways of doing the same work with opposite restriction. Okay, so this is how we do these kind of questions. Now look at this one. Total number of ways in which 0 to n things can be selected out of n things such that p are of one type, q are of another type, and r and the balance r of a given type is given by p plus 1, q plus 1, and 2r minus 1. Okay, 2r minus 1. So what they are saying basically that you are given that p things are alike. So you have 10 different pens and you have 12 different books. Okay, sorry, you have 10 different, sorry. This is statement. What this is saying, total number of ways in which we can select 0 to n things can be selected out of n things such that p are of one type, q are of another type, and the balance are of different types. Okay, so it is basically saying that let's say you have 30 things. Okay, let's say you have 30 things and you have 8 pens out of them, you have 9, let's say, books out of them, and those books are identical, and these are 17, 13 more things are left. So these 13 things are all different. These 13 things are all different. So we have a shoe, we have a lace, we have a tie, we have 13 different things. We have a fridge, we have an aeroplane. Okay, so what this statement is saying, that you have to select 0 to n things. Okay, so in how many ways you can do this? So basically I am saying that you can select 0 thing out of this, or you can select one book out of this, and you can select some other thing. Okay, so basically you are able to understand this thing. The question is saying that you have 0 to that you have n things. Okay, 0 to n things. Okay, let's say you have n things. Okay, and in those n things, p are of one type, q are of another type, and r are all different. So these are not identical, these are all different. Okay, so in how many ways you can do this selection? Okay, so that is given by p plus 1 into q plus 1 into 2r minus 1. Okay, so again understand this. If you have 0 to if you have to select 0 to n things, and we are saying p are of one type, q are of another type, and the rest are of different type. So how many ways you can do this? P plus 1, okay, q plus 1, and 2r minus 1, because these are all of different type. Okay, these are all of different type. Okay, but if you are given this condition, number of ways of taking some or all out of p plus q r plus r thing, such that p are of one type, q are of another type, and r of third type. So that is given by p plus 1, q plus 1, and r plus 1 minus 1. Okay, that is given by what? P plus 1, q plus 1, r plus 1 minus 1. So if there are 5 alike pens, 6 alike pencil, and 7 alike erasers, so find the number of ways of selecting one or more different things out of them. So we are excluding the condition of 0 here. There we were including the condition of 0. Okay, there when we were doing 0 to n, okay, in this we were taking the case of 0 as well. Here we are excluding the condition of 0. So in how many ways we can do this? P plus 1, q plus 1, r plus 1, and minus 1. Okay, p plus 1, q plus 1, r plus 1, minus 1. So this question will look like what? That we have 5 alike pens, we have 6 alike pencils, we have 7 alike erasers. But tell me in how many ways you can select one to all things. Okay, one to all things means that you can select one pencil, one pen, one eraser. So three ways of selecting one things. When you are selecting two things, you can do what? Either you can select two pencils, either you can select two pens, either you can select two erasers, or one pen and one pencil, or one pencil and one eraser, or one pen and one eraser. Okay, so these many number of ways are there. Okay, if you are selecting three things, so basically what you are doing, either you can select three pens, three pencils, or three erasers, or you can select two pens, one pencil, three pens, है ना, two pens, one eraser, and so on. Okay, so I hope you understand what we are trying to do here, what is the condition here. Okay, because it is very important to visualize your condition, then only you will remember that this formula we have to apply. Okay, then only you will remember that this formula you have to apply. And then you have this ncr divided by ncr minus 1 is n minus r plus 1 and r. Okay, so this is all these things. Now let us move forward. Now look at this. Number of selection of k consecutive things out of n things in a row is equals to n minus k plus 1. Okay, so number of selections of k consecutive things out of n things in a row. Okay, so basically what I am saying here, that suppose I have four apples and those apples are numbered 1 to 4. Okay, so I have apple number 1, 2, 3, 4, and I want to choose two of them. Okay, so if I want to choose two of them, any two of them, I can do it in 4C two ways. Okay, I can do this in 4C two ways. But if I want them to be consecutive, for example, if I'm selecting apple, so I'm selecting apple number 1 and 2, or 2 and 3, or 3 and 4. Okay, so in how many ways I can do this? So basically there are only three ways of doing this. Basically there are only three ways of selecting consecutive apple. So that is given by which formula? N minus k plus 1. What is n here? 4. What is k here? Minus 2. And what is 1 is 1 only. Okay, 1 is 1 only. So that is given by what? 5 minus 2 is 3. So you have only three ways of doing this thing. So remember this formula, because this was very simple. You can always do it, but when it will be greater number, then how will you do it? You won't be sitting counting. Okay. So remember this formula. Number of selection of k consecutive things out of n things in a row is n minus k plus 1. Okay. N minus k plus 1. Fine. So these are all the formulas. Okay. It is not formulas, it is actually formulae, we say. Okay, formulae. But now we'll move on to the questions. Okay. Um, so we have already done a lot of concepts related to permutation. Let's see about circular permutation. Now, circular permutations are a little bit different from linear permutations. See, if I'm giving you, let's say A, B, and C, these are three different people and you have to arrange them in three different places. So, how will you do in factorial three ways? Because three different people have to be arranged in three different places. So, that can be done in factorial three ways. And what does factorial 3 means? Factorial 3 means 3 into 2, that is equal to 6. Okay. Factorial 3 means 3 into 2, that is equal to 6. But that is not the same case with Okay, that is not the same case with circular permutation. Okay, so for example, if I'm having this arrangement, let's say ABC. Okay, if I'm having this arrangement, let's say ABC. Now look at this circle we have. You have ABC. I can call this arrangement as ABC. Also, I can call this arrangement as BCA as well, and I can call this arrangement as CAB as well. But if I am doing this ABC, BCA, and CAB, then these are not same in a linear arrangement, but that is same in a circular arrangement. So I hope you understand this thing. What I am saying here is that you have ABC. Okay, you have ABC. So this can be done in factorial three ways. Okay, this can be done in factorial three ways. Now, see, either you have this ABC, okay, you have this circle, and I am saying you're arranging in this way ABC. So this ABC is the same arrangement as BAC or CAB, okay. But if you arrange this thing linearly, then they are not the same, okay. These are different arrangements. So for three linear arrangement, we get one circular arrangement. Okay, for three linear arrangement, we get one circular arrangement. What can be another? See, let us see this. Now, this is earlier we were having A, B, C. Okay, so A, B, C was same as what? A, B, C was same as BCA, ABC was same as BCA and CAB. And then let us consider this arrangement. You have this ACB. Okay, you have this ACB. Okay, now this ACB clockwise is also CBA, is also BAC. So we have this three arrangements into one circular arrangement. So for six linear arrangement, there corresponds only two circular arrangement. So if we generalize this process, so for factorial n, let's say you have been given, you have to arrange in five people, you have to arrange in a circular arrangement, then it can be done in how many ways? So that can be done in factorial 5 by 5. Okay, factorial 5 by 5. So that is basically what? That is n minus 1 factorial or 5 minus 1 factorial, because that is 5 factorial. So 5 into 4 factorial divided by 5. So that is 4 factorial. So I hope you understand this. See here, when we were doing for six circular arrangement, you had two for six linear arrangement. For six linear arrangement, you had two circular arrangement. Okay, for six linear arrangement, you had two circular arrangement. Okay, so what we get here is we have this as 3. Okay, we have this as 3. Now if we generalize the whole process over factorial n, there corresponds to be 1 by n into n factorial. Okay, 1 by n into n factorial. So this can be written as what? 1 by n into n factorial is obviously n minus 1 factorial. Okay, here also when we did, then we did what? 3 factorial divided by 3. So that became how much? 3 into 2 divided by 3. So that is what? That is 2 only. So n minus 1 factorial you will get. Okay, if you want to arrange 4, 5, 6, n number of different people in a circular arrangement, so that is given by n minus 1 factorial. Okay. Okay, when clockwise and anti-clockwise observation are not different, then the number of circular arrangement of n different thing is n minus 1 factorial divided by 2. Okay, so what we are saying here, see, if you see the above example which we were considering, understand this thing very carefully. What this case is saying, see, if we are earlier what we did, in the earlier case we took A, B, C clockwise. Okay, now this is also A, B, C but anti-clockwise. So if clockwise and anti-clockwise arrangement are considered as same, okay, if clockwise and anti-clockwise arrangement are considered as same, so then number of arrangement, the number of circular arrangement that can be made is given by n minus 1 factorial divided by 2. So for three people, 3 minus 1 factorial divided by 2, which is 1 only. Okay, because 2 factorial divided by 2, you will get 1 only. So this ABC and this ABC anti-clockwise and this ABC clockwise are the same arrangement. Okay, this ABC anti-clockwise and this ABC clockwise are the same arrangement. So is this ACB clockwise and this ACB anti-clockwise is the same arrangement. So if we are not considering clockwise and anti-clockwise arrangement as different, then it will be given by what? It will be given by n minus 1 factorial divided by 2. Okay, so this is how we do these kind of questions. Now, number of selections of k consecutive things out of n things in a circle. Okay, see what here we are saying, that number of selections of k consecutive things out of n things in a circle is n when k is less than n and is equals to 1 when k is equal to n. Okay, see this k will be either less than n or k will be equal to n. So we are having this circle, and in this circle there are k consecutive things and we have to select only consecutive things. Okay, we have to select only consecutive things. Okay, so if k is less than n, then the number of ways of doing this thing is equal to n. Okay, if k is less than n, then the number of ways of doing this thing is equal to n. Okay, fine. This is for k is less than n, and if k is equal to n, and you have to select these in consecutive manner only. So that is one kind of arrangement, and that is done in one way only. Okay, that is one kind of arrangement, and that is done in one way only. So, for example, if we had three things, okay, we had three things, and we have, let's say, total number of things are 8. So we have 8 things placed this way. Okay, these are 8 things. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are 8 things. Okay, now if I am saying you have to select these three consecutive things. Okay, you have to select these three consecutive things out of n things. Okay, k consecutive things. So not only these three consecutive things, you have to select three consecutive things out of these 8 things. So let's see in how many ways we can do that. According to our result, we should get the number of ways should be 8. Okay. So let us consider this as one arrangement. Okay. Then we'll consider this one as another arrangement. So we get 1 here, we get 2 here. Then we'll consider this one as another arrangement. So we'll get 3 here. Okay. Then we get this one as another arrangement. So we get 4 here. Then we can consider this one as another arrangement. So we get 5 here. Then we consider this one as another arrangement or another selection. So we get 6 here. Then we can consider this one as another arrangement. So we get 7 here. Okay. And then we consider at the last, we consider this one as another arrangement. Okay. Because k consecutive things they are asking. So that is given by 8. So I hope I am able to prove this to you, that why this result comes. Okay, that why this result come, you can check and see. Okay, so see, we were asked to select k consecutive things. Okay, so any three k consecutive things you select and tell me how in how many ways you can do this. And you were having 8 things, so you can do this in 8 ways. I already showed you, I showed you these arrangements. Okay, so I hope everybody is okay with this, everybody understand this well. Okay, now let us move forward. Now see, this is very simple question. If you are asked that number of permutation of 6 things taken 4 at a time. So simply it will be given by 6p4 factorial 6 divided by factorial 4 and factorial 2. So this will be 6 into 5 and 2 into 1. So that will be given by what? That will be given by 15. Okay, that will be given by 15. Now let us move on to the next. Okay, we'll do very simple to very tough questions here. Okay, how many three-digit numbers can be formed out of the digits 1, 2, 3, 4, and 5? Okay, so you are given 1, 2, 3, and 4 of 5, and you have to form three-digit numbers. So basically, what we have to do here, 5p3, because that is what the arrangement select any three digits out of these digits. So that can be given by 5c3. Okay, and then this can be done in factorial 3 ways, and this is equal to what? This is equal to 5p3 also. So either you apply permutation or you apply selection, both are same. But in selection, when we multiply the case with the number of rearrangements we can do, that will give us the permutation. So 5p3 will give factorial 5 divided by factorial 3 into factorial 2, and this 5c3 is given by what? Sorry, this 5p3 is given by factorial 5 divided by factorial 2. Okay, because what is NPR? NPR is equals to factorial n divided by factorial n minus r factorial. Okay, and see, I am saying that if I do by this method also, that first what I will do, I will find out the number of ways in which 3 digits can be selected out of these 5 digits. So that is 5c3. Now this is the number of ways in which I can select 3 digits out of 5 digits. In how many ways I can arrange these digits? So that can be done by factorial 3. Okay, that can be done by factorial 3. So what are you going to get here? You are going to get factorial 3 divided by factorial 5 divided by factorial 3 divide into factorial 2, and this is factorial 3. So this is 5 into 4, and you are getting the same thing here as well. Okay, you are getting the same thing here as well. So how many 3 digit number can be formed out of the digits 1 2 3 4 and 5? So that is very simple. 20 into 3, that is 60. Okay, 60. So this is how you do these kind of questions. Understand this very well. These questions are very simple, but to enhance our understanding, we are doing very simple questions. Okay. In how many ways can 7 letters M, N, O, P, Q, R, S be arranged so that P and Q occupy continuous position? Okay. So that P and Q occupies continuous position. So we have this M, N, O, P, Q, R, S. Okay. So if P and Q have to occupy continuous position, we will do what? We will consider them these as one. Okay, these as one. Okay, so they will always occupy continuous position. Okay, now see, it is asking in how many ways 7 letters M and N M and O P Q R S can be arranged so that P and Q occupy continuous position. So if we consider this as one, so the number of ways in which these, now we are considered as one letter only. So the number of ways in which they can be arranged, so these are basically 6 letters because I am considering them as one. Okay, so that can be done in factorial 6 ways. And big C, if like for example P and Q are occupying continuous position, so it can be either in the form of P and Q or either in the form of Q and P. So these can be arranged in how many ways? Factorial 2 ways. Okay, so I'll multiply factorial 2 here. So total number of ways in which 7 letters M, N, O, P, Q, R can be arranged is given by factorial 6 into factorial 2. Okay, I hope you are very clear with this, what we did here. See, I am considering here, okay, I am considering here whenever something is given in such a manner that you have to keep this always together. Okay, so whatever you have to always keep together, consider this as one, and then calculate the number of arrangement. Okay, whatever you have to always keep together, consider it as one. Okay, and then calculate the number of arrangement. So when I took these both as one, the number of position in which arrangement I have to make is left 6. So that can be done in factorial 6 ways. But this P and Q are there now. So P and Q can also be written as Q and P. So if every position, factorial 6 position where P and Q are consecutive, if it could have been Q and P, so then write this as factorial 6 into factorial 2. So that is it. Okay, that is it. Fine. Now let us see this question. Of the different words that can be formed from the letters of the words begins, how many begin with B and end with S? Now see, this is very simple. you are given how many letters? 1, 2, 3, 4, 5, 6. So B at first and S at last. Okay. And how many letters you have to do here? E, G, I, N. So factorial 4 ways, because this and this will be fixed. So whatever arrangement will be done here will be done in factorial 4 ways. So the answer is simple, factorial 4 ways. Okay. Understand this question once more. See what I am saying. Of the different words that can be formed from the letters of the word begins. So B, E, G, I, N, S. Okay. So these are how many letters? 1, 2, 3, 4, 5, 6. Okay. But it is saying that begin with B and end with S. So fix B and S in the first and the last, and then you have 1, 2, 3, 4. So E, G, I, N. So this can be done in how many ways? This can be done in factorial 4 ways. Okay, this can be done in factorial 4 ways. So this is how we can do this. Now, in how many ways can the letters of the word valedictory be arranged so that all the vowels are adjacent to each other? Okay, so letters of the word valedictory. We have this letters of the word valedictory be arranged so that all the vowels are adjacent to each other. How many vowels are there? 1, 2, 3, 4 vowels are there. Okay, 1, 2, 3, 4 vowels we are getting. Okay, how many total words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so see, when vowels are always together, so these 4 we can consider as 1. So total we are 11. So now we are considering these 4 as 1. So this will become what? 11 minus 4 is 7, and 7 plus 1 is 8. So now factorial 8 ways, but this A, E, I, O should also be arranged in themselves. So this can be done in factorial 4 ways. Okay, this can be done in factorial 4 ways. See this is very similar to the earlier question what we were doing here. See, valedictory is given, and here it is saying that in how many ways can the letters of the word valedictory be arranged so that all the vowels are adjacent to each other. Okay, so we'll consider them as one. 1, 2, 3, 4 vowels are there. We are considering them as one. Okay, so just minus 4. Okay, 11 words are there, minus 4, and this will be 7 plus 1, 8. So factorial 8 ways you can do the arrangement in which the vowels are always together, but these vowels are all different, and they will have to be rearranged themselves also. Because for example, let's say we are having this A, E, I, O. Okay, this is our first arrangement, and then we are having all those 7 words. Okay, then there can be another arrangement, A, E, O, I. Then there can be another arrangement, A, O, E, I. Okay, and then there can be another arrangement. Okay, A, I, E, O. Okay, so in this way we have to also calculate when these are exchanged. Okay, so this can be done in factorial 8 into factorial 4 ways. Okay, so I hope now this is very clear to you. Now you can obviously calculate. Okay, you can Okay, you can obviously calculate factorial 4 into factorial 8. Okay, if it is asked to calculate, see, factorial 4 is what? Factorial 4 is 24, because 4 into 3 into 2 into 1 is 24. Okay, and what is factorial 8? Okay, what is factorial 8? Factorial 8 is 8 into 7 into 5 into sorry, 6 into 5 into 24, because factorial 4 is 24. Okay, so you know this is 30, this is what? This is 56. Okay, and obviously now you can calculate. Okay, so how will calculate? See, there are some easy ways to calculate. For example, this is 30. So instead of multiplying, okay, instead of multiplying the whole, what we can do here, just multiply this 24 into 3. What is 24 into 3? That is very simple, 72. Okay, 24 into 3 is 72. Fine. So 72, okay, this is 12 on 72. This will become 720 into 56. Okay, now just multiply 72 into 56. So what are you going to get? 12 here, 7, 6 are 42, 43. This will be 10, 1, and 35, 36. So 2, 3, 0, 4, 0, 3. 20. Okay, so this is so sometimes you need to calculate also now, because it will not be given factorial 80 to factorial 4. Okay, sometimes you have to calculate as well. Okay, fine. Let us move on to the next question. What this question is saying, if there are two kinds of hats, red and blue, and at least five of each kind, in how many ways can the hats be put in each of five different boxes? Okay, see now what you have here in this question, you are having two kinds of hats. You have red hat and blue hat, and you have five of each kind. So total you are having 10 hats. Okay, total you are having 10 hats and at least five of each kind. Okay, if there are two kinds of hats, red and blue, and at least five of each kind, you are having at least five of each kind, and you can have more than five also. Okay, so in how many ways can these hats be put in five different boxes? Okay, you have five different boxes. In how many ways these hat can be put? See now what we can do. Okay, so let's attempt the solution. Okay, so try to understand what we can do here. See, what you have here is basically that you have this box. Okay, and there are two ways of filling this box. Either you can put a red hat or you can put a blue hat. There are two ways of putting hats in this box also. Either you can put a red hat or you can put a blue hat. There are two ways of putting this also. Either you can put a red or blue, red or blue, red or blue, red or blue. So you have this 2 to the power 5. So what is 2 to the power 5? That is 32. Okay, what is 2 to the power 5? That is 32. So I hope you are very clear with this thing. Okay, I hope you are very clear with this thing. Now see, there is one more thing. See, what is another way of thinking about this? Okay, see, another way of thinking about this is you have five tasks. Okay, you have five tasks. Okay, because you want to put hat in boxes, you have five tasks, and you have two ways of doing each task. Okay, you have two ways of doing each task. So that will be given by what? 2 to the power 5. Okay, you have five tasks and there are two ways of doing each task. So that is given by 2 to the power 5. Okay, so this is also simple. You can think in this way also, because this we have studied already. That if we have five places, okay, so either you can put a red hat or a blue hat. You have two ways of doing this. You can also do this in two ways, do this in two ways, do this in two ways, and do each of them in two ways. So you will have 2 to the power of 5 ways of doing this. Or you have five tasks to be done. You have two ways of doing each task. So that can be done in 2 to the power of 5 ways. Okay, that can be done in 2 to the power of 5 ways. Now look at this. In how many ways can four Indians and four Nepalese people be seated around a round? See how, look at this question. We have this. In how many ways can four Indians and four Nepalese people be seated around a round table so that no two Indians are sitting in the adjacent position? Okay. So we have this as, it is saying four Indians and four Nepalese people have to be seated around and no two Indians are in adjacent position. So first place four Indians. Okay, four Indians. So in how many ways four Indians can be arranged? Okay, how many ways four Indians can be arranged around a circular table? Factorial three ways. Okay, now we have four places left to be Nepalese to be seated. Okay, we have four places left to be Nepalese to be seated. Now this is Nepali 1, 2, 3, 4. You have four people and they can be arranged in how many ways? Factorial four ways. So this is given by factorial 3 and factorial 4. See, it is asking in how many ways four Indians and four Nepalese. Okay, so that no two Indians are together. So if no two Indians are together, so that means there is always a Nepalese between two Indians. Okay, there is always a Nepalese between two Indians, because that is only the case. If you keep two Nepalese between two Indians, so then one case will come there, two Indians will come together. Okay, two Indians will come together. So we don't want that. So see, this will be the alternate arrangement. Okay, so that we first place four Indians. Okay, we plus first place four Indians. So four Indians can be arranged in a circular table in how many ways? Factorial three ways. Now only we saw that n people can be arranged around a circular table in n minus 1 factorial way. Okay, n minus 1 factorial way. so that no two Indians are in adjacent position. Now there are four places for Nepalese to be seated, and all Nepalese are different people. So that can be done in factorial four ways. So you have factorial 3 into factorial 4. So I hope this is clear to everybody. Now let's move on. See, now what the question is saying, how many numbers greater than a million can be formed from the digits 1, 2, 3, 4, 0, 4, 2, 3. Okay, see, it is asking how many numbers greater, how many digits, 1, 2, 3, 4, 5, 6, 7 digits are there. Okay, and it is asking how many numbers greater than a million. So, in a million, how many digits are there? 1, 2, 3, 4, 5, 6, 7. Okay, in a million, 7 digits are there. Okay, but it is asking how many numbers greater than a million. Okay, how many numbers greater than a million can be formed. Okay, now see, when it is asking about greater than a million, now there are how many digits? 1, 2, 3, 4, 5, 6. So here I can place how many? I cannot place 0 here. So this number can be filled in 6 ways. Okay, this number can be filled in 6 ways. Now this can be filled in how many ways? Obviously 6 ways. Okay, obviously 6 ways. Now see, because these digits are given, so 3 and 3 is given, so that means, and 2 and 2 is given, so that means whatever number are given, we have to choose them only. So once we are choosing one number, then we can't choose that number again. Okay, so that can be done in, this can be filled in 5 ways, this can be filled in 4 ways, this can be filled in 2 ways, this can be filled in 2 ways, and this can be now filled in 1 way only. Okay, now see, there are some numbers which are similar. For example, this 3 and 3 is similar, this 2 and 2 is similar. So if the arrangement is there, so we have to divide this by factorial 2 into factorial 2. Okay, so we have to divide this by factorial 2 into factorial 2. Now this is what, this is factorial 6, and this is what, this is 6, and this is factorial 2 into factorial 2. Okay, so we have 6 into 5 into factorial 4 divided by factorial 2 into factorial 2. So we have this 3 and 3, and we have this 9, 5, 45, and this is 24. Okay, this is 24. So 45 into 24. Fine. So understand this once more. It is saying how many number greater than a million can be formed from the digits 1, 2, 3, 4. So these 7 digits are there, and you have to do, you have to use these 7 digits only. So take this 1, 2, 3, 4, 5, 6, 7 positions. In the first position, you will obviously not put 0 because it is asking million or greater than a million. So this can be done in 6 ways. Now this can be also done in 6 ways. This can be done in 5, 4, 3, 2, 1 ways. But because this 2 and 2 are similar and this 3 and 3 are similar, so whatever arrangement will made by this 2 and 2, for example, this 2 is here and this 2 is here, or this 2 is here and this 2 is here. So they are basically the same arrangement. So because of that, we are dividing by factorial 2 here, and because 3 is also there 2 times, so we are dividing by factorial 2 here. So we have 6 into factorial 6. What is 6? 5, 4, 3, 2, 1. Factorial 6 only. So I am writing factorial 6 here. So you have 6 into factorial 6. Okay. So you have this. Okay. You have this. Now let us move forward. Now look at this. If there are 11 players to be selected from a team of 16, in how many ways this can be done? So this is very simple, 16C11, okay, because just selection they are asking. So that will be 16C11. There are 11 players that have to be selected from a team of 16. So very simple, 16C11, okay. Now let us move forward. In how many ways 18 identical white and 16 identical black balls be arranged in a row so that no two black balls are together. Okay, so that no two black balls are together. Okay, so see, first of all, understand this. In how many ways 18 identical white and 16 identical black balls be arranged in a row so that no two black balls are together. Okay, so first we'll do what? We'll put white balls. Okay, white balls 1, 2, 3, 4, 5, 6, 7, 8, 18 white balls we'll put. Okay, so how many places will be generated for black balls to come in? 19. Okay, 1, 2, 3, 4, 5, 6. You can count this. 19 places will be generated for black balls to sit. Okay, 19 places will be generated for black balls to sit. Now these 16 black balls have to select out of these 19 places to sit. So they have to select, okay, 16 black balls have to select out of 19 places. So that can be done in 19C16 ways, because 16 black balls have to select from 19 places, okay, because 18 white balls will make 19 places, okay. 1 2 see, if the question would have been in how many ways, 6 white balls and 3 black balls, identical black balls be arranged in a row so that no 2 black balls are together, okay. So 6 white balls, if I am placing 1 2 3 4 5 6, I am placing these in alternate manner. How many places are generated? 1 2 3 4 5 6 7. So you can put now your here another balls, okay, you can put here. But if there are, these are 16 white balls, sorry, 6 white balls and 3 black balls have to be put here. In how many ways they can be put? So they can be put in, see, 3 black balls have to select from 7 places, okay. So that can be done in 7C3 ways. Arrangement here is not important, though the question says about arrangement. Why? Because these are all identical balls. What difference does it make that if we put one ball here and one ball here? So we'll not use permutation here, we'll use only combination, because we have to select the places, okay. Do you understand it? We have to select the places here, not the balls here, okay. So the number of balls have to select the places in which they want to sit, okay. And these are all identical, it does not make a difference that which place they are sitting. It is just the arrangement they are choosing, okay. So whether if there are 3 balls, whether they are choosing this and this place, or this and this place, or this and this place, okay. So you understand this thing, actually what we are counting, okay. It's very important in permutation to understand actually what we are counting, okay. So this is how we do these questions, okay, fine.